In this brief lecture, we're going to talk about some cool functionality in Swift that allows you to manipulate collections. That is filter and map. We use filter and map as part of the Mexagram tutorial. So what are filter and map? Filter and map are functions that allow you to manipulate collections by applying a transform function. We take an array, for example, in a certain state, then we provide a transform function, and map or filter will return a new array that is transformed by the function that we provide. Let's take a look how these two functions can be used practically. We will start by taking a look at an example of filter. Filter allows us to provide a function that will be applied to every single element to define if it remains in an array or not. That allows us to remove elements from an array that don't meet a certain requirement. Let's take a look at an example. In this example, we have a user, and the only property that that user has is their age. We create an array of users, and then we want to filter that array. We only want to keep users in that array that are younger than 16 years old. We can do that by calling the filter function on that array. The filter function takes a closure, and inside of that closure, we can define a certain requirement that all elements have to meet to remain in the array. Note how we are using a variable called $0 inside of the closure. In Swift, we can access all arguments to functions by taking a $sign and then the index of the argument. In filter and map, it's a typical convention to access the argument to the closure using $0. The function that we are providing here inside of the closure will be applied to every single element, and each element will be $0 at one point in time. So imagine we have 3 users in the array, then filter will be called 3 times, passing each user in separately. We'll see that as an animated example on the next slide. For simplification reasons, I have talked about the array as if it would be manipulated, but actually, this filter function returns an entirely new array. That new array is stored in young users in this example. The old array remains unchanged. Let's take a look at an animated diagram of how the filter function works. Here is what our filter function looks like, and here's an animated example. On the left-hand side, we have an array that contains 4 elements that represent users, and you can see their age, 20, 13, and so on. When we apply the filter function, then all of these elements will go through that filter, and only the elements that meet the requirement that we specify will be returned in the new array that this filter function creates. So first we take a look at 20. 20 is not smaller than 16, so this element does not land in the new array. Next we take a look at 13. 13 is inside of the new array because it is smaller than 16. Next we look at 35. 35 is not inside of the array. And lastly we look at 12. And 12 is inside of the array. So by applying this filter function, we got an array initially that had 4 users in it, and we get a new array returned that only has 2 users in it, both users that fulfill the requirement of the age being smaller than 16. Next, let's take a look at how we can use map. Map is similar to filter because it also transforms an array by applying a certain function to every single element inside of that array. However, unlike filter, it never changes the size of the array. It only changes the elements inside of the array. Map can replace each element of array A to create an array B. Let's take a look at an example. We again have a user struct, but now we have an age and a name. We create a list of users and store it in a users array. We now want a new list that only contains the names of the users, but no user objects. That is a great use for map, because we can apply a transformation to each object inside of the array. In this case, the transformation is extracting the name and returning that instead of the entire user. You can again see that map takes a closure, and inside of that closure, we have to return a value that shall be stored in a new array. Let's again take a look at a visual example. In this case, we have 2 users in the original array, and in the output array after it went through map, we only have their user names. So map is used to transform certain objects into a different representation. For example, extracting fields from objects and representing them in an array. We use this example as part of the Mexagram tutorial. Another example for map that is a little bit simpler is, for example, multiplying all numbers in an array by 2. Here on the left-hand side, you can see an array with 4 numbers. And above the diagram, you can see the map function that we are applying. We're saying multiply every element by 2. The resulting array, after running through map, is an array that also contains 4 numbers, but each of them have the double value than the original array. Map and filter can also be combined. Let's take a look at this more extended example. Here we now have users that have an age and a name, and what we want to do is generate a list of usernames of users that are younger than 16. Essentially, we are combining the 2 examples that we showed earlier into one. We're taking the users array, and we're first applying the filter function to remove all elements that don't match our requirements. Then, on the remaining set, we call map to extract the username from these users. Here the input is an array that contains 2 users, and the output is an array that only contains 1 username, the username of the only user that is younger than 16. Map and filter are really powerful tools. Take a look at how we use them in the Maxogram tutorial and see if they can be useful in your own apps.